So in previous section, we will discuss about AM transmitters. We know that the two types of AM transmitters we have. One is a low level AM transmitter and a high power level AM transmitter. So after, and in this class, I'm going to explain you about FM transmitter. So depending on the type of modulation technique we used, we can classify these transmitters into AM transmitters and FM transmitters. In FM transmitter, the modulation technique which will be used is the frequency modulation. We know that the frequency of the carrier signal will be varied with respect to the amplitude variations in the message signal. And in this, we use a frequency division multiplexing that will be used in FM transmitter. So here the FM transmitter block diagram will be classified into six main stages. One is a preamplifier stage. Here the audio signal will be amplified. And after that, a high pass filter section that is also called a free emphasis network. At high frequencies, the modulating signal strength will be very, very low. So thus at high frequencies, this free emphasis circuit or network boosts the signal strength, increases the signal strength. And after that, we have the modulator section. For this modulator, one is the audio frequency signal that will be amplified and free emphasized. And another input is a carrier signal that will be generated from an oscillator circuit. Here the oscillator is RF oscillator. It generates a radio frequency signal that is called RF signal. And the FM modulator, here the FM modulator output will be modulated output, that is the frequency modulated wave we will get at the output. And after that, this frequency modulated wave is passed through the frequency multiplier sections. If the operating frequency is not enough, we use here the frequency multipliers. So that is depending on the requirement. The number of frequency multipliers we used here is depending on the requirement. And after that, this FM signal will be passed through the power amplifier section. If the modulated signal power level is not sufficient, so it will be power amplified by the power amplifier so that it can travel the long distances. And after that, it will be given to the antenna that is called transmitting antenna. So here you may observe the audio signal will be amplified by the preamplifier section, which increases the boosts the signal, modulating signal. And then it will be passed through the high pass filter section. It acts as a free emphasis network. So at high frequencies, generally modulating signal will be attenuated at high frequencies. At high frequencies, we can increase the signal strength by using this free emphasis network so that we can improve the signal to noise ratio at high frequency. So signal to noise ratio of the modulating signal we can improve by using this free emphasis network. And the signal is further passed through the FM modulator that is called a frequency modulator circuit. And this generates a high frequency modulated signal, and this will be passed through the frequency multiplier sections. So in order to increase the operating frequency, and then the modulated signal, and then the power of the modulated signal will be not sufficient. It will be given as input to the RF power amplifier, and this power amplifier increases the power level of the modulated signal so that it can travel the long distances. So here finally the output, finally the FM modulated output is finally passed through the antenna to get transmitted. So these are the main blocks included in the FM transmitter, FM transmitters. These are the main blocks. We have a free emphasis network at the transmitter, and we have the FM modulator and frequency multiplier, and then power amplifier. After that, we have the transmitting antenna. So in FM transmitters, the type of technique used is the frequency modulation technique, which will be used. We know that the frequency modulation, the frequency of the modulated signal or carrier signal will be varied with respect to the amplitude of the message signal. So means here the frequency variations depending on the amplitude variations of the modulating signal, so that the FM transmitter can be used in radio and TV and broadcasting wireless transmissions. Okay, so here we have different methods to generate FM signal. So we can generate the FM signal by using a direct method and also by using indirect method. So in direct method of generation, we can generate directly the frequency modulated signal. And in indirect method, by using phase modulated, we can generate the frequency modulated signal. And after that, first you have to generate the narrowband frequency modulated signal, and after that you will get the wideband FM signal. These are the indirect methods. And in direct methods, we can directly generate the frequency modulated signal. So we have the different techniques to generate the direct method, direct FM. So here the direct modulators are varactor diode modulator, reactance modulator, and one is VCO, and another one is cross by direct FM. So this is very, very important, cross by direct FM transmitter in this automatic frequency control unit we have. And another one is stabilized reactance modulator. So this VCO and cross by direct FM will be, these two are the important direct methods of generation of FM. Okay, so we know that in varactor type and in reactance modulator, so whatever the device we are taking, so here the device reactance will be varied with respect to the amplitude variations in the frequency in the modulating signal. So in the reactance modulator and varactor diode method, so here whatever the device will be used, that frequency will be varied with respect to the amplitude variations in the message signal. So here you may observe in this reactance modulator, so here we are considering a transistor or FET. FET, it will be operated as a variable reactance, and whose frequency will be varied, means whose reactance will be varied in proportional to the amplitude or the applied voltage at the input. So here the reactance of the device will be varied with respect to the amplitude, with respect to the applied input voltage at the applied voltage at the input. Okay, so that is nothing but a reactance modulator and the varactor diode modulator. And another one is the cross by direct FM transmitter. In this cross by direct FM transmitter, we have the main functional unit that is called automatic frequency control loop. Automatic frequency control loop. And these are the characteristics of the cross by direct FM. In this, phase deviation will be increased by using the frequency multiplier. And here we have the mixer circuit and band pass filter. And we have the discriminator, that may be frequency discriminator or phase discriminator, that is depending on the requirement. Okay, so here you may observe the block diagram of the cross by direct FM transmitter. So in FM transmitter, what are in general, what are the main blocks included in the transmitter? In transmitter, we have a modulator, and then we have the power amplifier, and then we have the transmitting antenna, right? So this is the frequency modulator. This is the frequency modulator, and this modulator, modulating signal, is the input. In this frequency modulator, we have an internal oscillator that will be generated, a carrier signal having the frequency 5.1 megahertz. So finally, what you will get here, the modulated signal at its output. And this modulated signal will be passed through the frequency multiplier sections. So what is the purpose of frequency multiplier? If the operating frequency is not sufficient, we use frequency multiplier sections in order to increase the operating frequency. So here we are considering 3 frequency multipliers. So finally here we will get F1, and here we will get F2, and finally here we will get Ft. This is the transmitted frequency. So what is the carrier signal frequency here? 5.1 megahertz. So that will be generated, means modulated signal frequency will be 5.1 megahertz. After it will be passed through the frequency multipliers. So finally what we will get here, it will be 91.8 megahertz transmitting frequency. Means here the operating frequency will be increased when it will be passed through the frequency multipliers. And after that we have the power amplifier section, and after that it will be given to the antenna. So depending on the modulation, here we have to use a automatic frequency controller loop. This AFC automatically adjusts the carrier frequency. Adjust the carrier frequency. In this automatic frequency control, we have the main blocks, mixer, band pass filter, and a discriminator. Generally, what is discriminator? It converts the frequency variations into the voltage. Here the purpose of discriminator. So here the frequency discriminator, it will be convert the frequency variations into the voltage. Okay, so here the modulated signal will be given to the mixer, and this mixer we have 2 inputs. One is a crystal reference oscillator, so whose frequency is 14.3 megahertz. 14.3 megahertz. Here you may observe it will be converted into the down frequency of 5.1 megahertz. So depending on the requirement, so we can adjust the frequency. We can adjust the frequency which is required for the transmission. So here you may observe this crystal oscillator frequency is 14.3 megahertz. It will be multiplied by, here we use a frequency multiplier that will be doubles the frequency, that is equal to 28.6 megahertz, and it will be given to the mixer. So here the mixer is non-linear mixer. So we already discussed about the mixer in a super heterodyne receiver. So we can convert the frequency to up level. We can convert the frequency into down level. So this is the down converter. So finally what we will get here, 2 megahertz. 2 megahertz frequency. This 28.6 megahertz frequency will be converted into the 2 megahertz frequency, and these frequency variations will be converted into the corresponding DC voltage, and we have a low pass filter section. So finally it will be applied here. Okay, so this is automatic frequency controller, and this is the method is crossed by direct FM transmitter. So we can adjust the frequency by using automatic frequency controller loop. Okay, so and another one is direct FM transmitter using PLL. So these are the direct methods to generate the FM signal. So in direct method, what we call it as, one is Armstrong method and another one is by using PLL, phase locked loop. Phase locked loop. So this PLL will in this PLL, what we will get at the output is a wideband FM signal. Wideband FM signal. In PLL, we have one of the block is a voltage controlled oscillator and a low pass filter and a phase detector. And a phase detector here. So here the modulating signal will be input to this adder, and the carrier crystal oscillator, we have the phase detector and frequency divider and voltage controlled oscillator. So finally, we will get the wideband frequency signal. For the wideband FM, the quality factor is very, very low in PLL. The quality factor means Q factor for this filter is very, very low. So that is the direct method to generate the frequency modulated signals. And another indirect method is called Armstrong method. Armstrong method. So this is an indirect method of generation. In this indirect method, first you have to generate the phase modulated signal and then it will be converted into the frequency modulated signal. Means by using phase modulation, we will get the FM here. And we use a crystal oscillator in this. It will produce very stable frequency and the quality factor is also very, very high. So in indirect method that is called in Armstrong method, what are the advantage is, here we use a crystal oscillator. It will produce the stable frequency and the Q factor is very, very high. And here we can get the FM signal through the phase modulation, through the phase modulation. So this is the Armstrong method. This is another method that is called indirect method of generation. So in this indirect method, first by using phase modulation, you will get the FM wave that is called narrowband FM, and it will be passed through the frequency multiplier sections. You will get the wideband frequency modulated signal. We know that the purpose of frequency multiplier here, so it increases the operating range, so that you can get the wideband FM at the output. So in Armstrong method, that is called indirect method of FM. Indirect method of FM, what we have to use a phase modulator. First you have to generate the phase modulated signal. So from this phase modulator, you will get the narrowband frequency modulated signal. It will be passed through the frequency multipliers. Finally, you will get the wideband FM. That is called Armstrong method. So this is the actual blocks representation, how the narrowband FM will be at the output by using a phase modulator. So this is the internal diagram of the Armstrong method. So first M of t will be integrated so that we will get the phase modulated signal. After that, the carrier frequency will be shifted by -90 degrees. And this will be given to the adder. You will get the narrowband FM signal at the output. And this will be passed through the frequency multiplier sections. And we have the amplitude limiter in the FM transmitter. And we have frequency multiplier. So finally, you will get the wideband signal at the output. Okay, so how the phase modulated signal, from the phase modulator, how can we get the narrowband FM? So first, the message signal will be integrated by using an integrator, and the carrier frequency will be shifted by -90 degrees. So you can get the sinusoidal signal. These two are added by, subtracted by the subtractor. You will get the narrowband FM signal, and it will be passed through the frequency multiplier sections. You will get the wideband FM at the output. So this is the elaborated block diagram representation for the Armstrong method. This is called indirect method to generate the FM. Okay, so here the modulated signal will be integrated. So finally you will get the output. We are taking A of t, and it will be given as input to the DSBSC modulator, and the carrier is shifted by -90 degrees, and these two will be added. Finally, you will get the narrowband FM, and it will be passed through the frequency multiplier. So finally you will get the modulated signal will be 12.8 megahertz, and the frequency deviation is 1.6 kilohertz. By using mixer we can convert this frequency into down frequency or up frequency. So it will be converted to the down frequency, and after that we have to use a frequency multiplier. So finally you will get the wideband FM signal at the output. So this is the Armstrong method to generate the FM, wideband FM from the narrowband FM. Okay, so same diagram how it will be generated, and these are the expressions. This is the phase modulated output. After the integration you will get the frequency modulated output. So we know that these are the blocks of crystal oscillator generates the stable frequency signal, means the Q factor is very, very high. If Q is high, stability factor also high. And the phase modulator, from this you will get the narrowband FM, and from the frequency multiplier it increases the range of the frequency range, so that the frequency deviation also increased. And the power amplifier, it gives the required power level to transmit the signal to the antenna. And antenna is a device. We know that it will be used for the sending purpose, and it can also receive the information. So this is the Armstrong method. So from this Armstrong method you can get the FM signal by using a phase modulated signal, and this is also called indirect method of generation. And when we compare the AM modulated and FM modulated signals, what are the differences between them and what are the comparisons? And for the AM signal transmission, it needs a smaller transmission bandwidth, but FM, it need a large bandwidth. And we can operate this transmitter by using low, medium, and high frequency bands, and FM will be operated at very high frequency bands. And the drawback in the FM is it will be limited to the certain range. It will be restricted to 50 kilometers, but in AM it has a wider coverage. And also here the demodulation procedure is simple, but the process of demodulation is complex here. And the system has poor noise performance, and here the stability is very, very high compared to the AM. Why? Because by using crystal oscillator we will get here the frequency stability at the output. Okay, so this is all about FM transmitter. We have direct methods and indirect methods. And indirect method, we have the classification. First one is the Armstrong method, and another one is PLL. So these two are the indirect methods. And indirect method of generation. So what are the methods in direct methods? Cross by direct FM transmitter. Here we use the automatic frequency controller, and we have variable reactance type and varactor diode and VCO. So by using VCO also you can get the FM signal. Okay, so these are the methods to generate the FM. So direct methods and indirect methods to generate the FM signal. Thank you.